Hello class, Dr. Mike here. So looking at part 2 of our chapter 1 for Introduction to Operating Systems. And we're picking up where we left off. Last time we were talking about hardware, configuration, firmware, and so on. We're going to now kick off here the textbook right about to overview of functions of an operating system. So there's some great stuff here. If you go to the textbook, we'll try this and so on. But we're going to focus on this one graphic right here, which is a great graphic actually. It sort of looks like a brain, but this is what an operating system does. We're going to just briefly discuss each one. So first off, let's talk about the user interface. That's pretty straightforward. You'll see our UI is referred to as UI. You refer to as a GUI. There's also a command line interface, CLI. So our UI itself, GUI, graphical user interface, which you're seeing right now on my screen. I'm with my Mac, or we have Windows open. It's a graphical user interface. CLI is a command line interface. That is going to be like our command prompt in Windows. It could be our terminal here in which I have here for both Mac and in Linux. Same thing. So. And of course, the biggest part of this is to make us to customize it or make it easy to use and or access underlying functions. So pretty straightforward. User interface, we can remember that one there. All right, so for second part here, job management and task management. So job management, task management are two things here. Jobs and tasks. So probably the biggest example I can give you is from Windows here, our task manager. So you remember in Windows, you right click into task manager, do Control-Delete. When you first do it, you'll actually get this. You'll probably get a sort of summary one like this right there. Here we see our running apps and we see our running processes. So a job and task. So think about our services and our processes here. Services can be things that start when the computer starts. These are things we might not deal with. It could be like BitLocker, or of course our networking services, NetProm, Netmon, and so on. These are networking logins. It could be running on start. They could stop when they're not needed. Plug and play services. You plug in like a USB or a piece of hardware. So these could actually run one or more processes attached to them. So these we refer to as tasks. So a job and task are very similar in a lot of ways, and the textbook probably does a better job of laying this out. So jobs can also be things that are scheduled. These are like backups, updates, things like that. Print jobs. My task could be running the actual app. So I'm running Word as a task. So it needs memory, it needs to access files. That's why you see this is also connected as a puzzle. And of course, it needs to have a user interface to interact with my GUI. When I click print, it's going to send it to a print job. So it's hard to distinguish. There's a lot of overlap sometimes between tasks and jobs, but you can see those a lot of times in our task manager in Windows or our activity monitor here in Mac. You can see stuff here too. So big one, memory management. So managing memory is very critical. There's a couple things about memory management without getting too in depth. One of them being this. We need to actually, of course, map our entire memory. So we have something called virtual memory. Now this is not the virtual memory I mentioned before, which is sort of swap space. This is really a way to hexadecimal sort of count out and so on, and map to physical memory, or actual memory space. This is their actual, think of slots, something like that too, and so on. Now this could be in different areas of our physical memory. And what we do is it allows us to go and create a map, this memory map. And of course, we take this also and we break it up into different spaces. We have something called user space and reserved space or protected space or kernel space, has different names. And the idea is for security, which is another thing here. Security is a big thing. We want to protect valuable or very vulnerable processes or parts of our OS from the user space. So this is what you want in Microsoft Word, Notepad, iTunes, things like that. And then we don't want those to actually interact with protected areas of our memory. So this gets mapped out. I don't get too in detail, but we map out stuff. This map allows my application, my app, just to write to what it thinks is an area reserved for it. When in actuality, it could be different each time I run my app. It could be here one time, it could be here next time. So it's a very complicated process, memory mapping. And of course, memory management is a huge deal. If it's slow, we have the slow computer. We get the hourglass or the spinning beach ball on Mac. We don't want that. And this also ties in with file management. So file management, we'll do this here, we'll clear it out. We'll talk about how file management is done with the operating system. So first off, I'm going to use the good old spinning hard drive as my example. So it's going to depend on the OS, but we need to take our hard drive. We need to somehow, whether it be an SSD or an old hard drive. I say old, still around. I mean, for the cost, 5 terabytes is cheaper compared to an SSD still. Someday there won't be no more spinning drives, but for now though, it's possible actually in my gaming laptop down here, I have an SSD for the OS, and I have like a 1 terabyte spinning drive for my Steam storage, things like that. Whether it's this SSD or not, we sort of take this, I'm going to use this as my example, we break it into sort of chunks. We have to be able to manage this. So we break it into sectors. Each sector we might break into have tracks. That's horrible there. And we might take this and break it into what's called blocks. This block itself will have a certain size. It depends on the OS, typically 1024 or 512 bytes or 1024 bytes in size. It could be larger than that. It's going to depend on the OS. And we need to map all this. So file management is going to go ahead and say, well, your Microsoft Word document starts at block, sector 2, block 86. And that's where it starts, but never actually is contiguous. It actually is fragmented. So part of this block is where to find the next part 2, and so on. So our operating system does this formatting. It formats our drive, whether it be an SSD, breaks into blocks, and it maps everything into a sort of file allocation table, a FAT table. So where is my Microsoft Word document? Well, it starts here, and it might go to here, and then it might be written to here because of word leveling for SSDs, and so on. And also we have things called journaling. So when it writes here, there is a small chunk of code that sort of verifies the data block itself. It's usually called an integrity check or integrity hash. And it also will actually write a secondary block somewhere too, possibly. Or write the changes that made the block. So this FAT table actually is got more than just a pointer, whereas at start it actually has that information about the block itself, the health of the block. What happens if a piece of drive, SSD or spanning drive goes bad? We want to be able to recover that. Once the computer gets unplugged, power goes out, you want to be able to recover your data. So this integrity checks are built in, integrity checks as well as security. And so part of this information about the block itself, we have information about the block. Let's take this block here. So the data itself is only part of it. Again, we have our integrity hash, our integrity check. We have our security information. If it's NTFS, it's going to have information about journaling, metadata about the block, when it was last accessed, where the previous block is from. So there's a lot of information that goes beyond just the data. So the data is just part of it. Again, a big part is security. And how this is done, how we break this stuff up and handle it is our format, our drive formatting, our drive, and this usually is referred to in Windows. We'll use Windows as examples, NTFS. And we will see here, I go into Windows, and there's our File Explorer again. Part of our GUI, you can see we interacting, right? Our interface, graphics interface, ties in with memory management, which ties in with file management. You can see it's all sort of taking place here. If I go to the computer itself, this PC, which is a virtual machine, which is stalling on me, so I'll come back to that in a second. Oh yeah, good old computers. Other things you might see though, you might see FAT32, VFAT. Simple as a thumb drive. If you buy a thumb drive, it's probably going to be FAT32. Here we go. So here's our drive itself. Right click, get properties. You can see this drive is NTFS right there. So properties, again, Windows right click properties is going to give you a lot of information. Right here you can see it's NTFS. That's a file system type. So again, what we do here, how it's formatted is gonna, there's ext4, ext3. There's tons of different formats for Linux, Riser FS, all kinds of different things. Let's just focus on FAT32 and NTFS. Those are the two main ones. And there's limitations. NTFS, a lot of security, journaling. You have security down into the file level. So if someone logs in, they can do encryption, for example. You can encrypt. I can encrypt my entire home drive. So like my C user, my documents could be my entire home drive. I say home drive, my home location here. So this right here, C users. So this could be actually encrypted within Windows, within Mac. Again, this is interaction between our security architecture and our file management architecture. So you can see that touches on there too. Same thing with Mac, Linux. I can do encryption, protection. So I can't log in as another user and just see, user Bob's files. So another big thing here, of course, is the file size. All up-to-date NTFS, ext4, and so on can have large files, huge files in size. FAT32, kicker here being 32-bit, can only have a 4 GB file limit. So back in the day, it was fine. There was no such thing as over 4 GB file. Nowadays, though, of course, image files, video files can get very large, and 4 GB can actually exceed that. Virtual machines, for example, can run very large files. So keep that in mind. If you buy a thumb drive, you go out and you buy a good old thumb drive, and you try to put a 6 GB image on there and it doesn't fit, it could be because it's FAT32. So that's a huge part of this chapter here, is just really focus on this. There's other examples here probably are going to give you, that I can't give you itself. Device management. So device management. I mentioned it before briefly with the previous lecture, but when we deal with devices, we need to have, let's go back to that. We need to have, I need a way to wait for Windows to talk to my video card and exploit everything it has, right? All the 3D graphics it can do, all the memory space. This is called, again, our device driver. And it's mentioned in the chapter. So also device management itself, how it's configured and so on. And we'll come back to this later, but there's a device manager. I'll use Windows as my example. We can see all of our devices. We can see, look, there's, with speed itself, there's the 3 gigahertz and so on. Batteries, input, output, and so on. This is a virtual machine, so it's probably going to be a little limited. But right-click Properties, and we get information about our device. So again, we're going to come back to Device Manager later in the course. I just want to show you real quickly right now, at least in Windows. We will come back to that later. So again, real important, this is really great to see how the operating system ties together and how it works. Memory management, security, and so on. So we should wrap it up here. booting up. I think I mentioned it before. When a computer boots up, let's go and clear the screen off here. When a computer boots, again, our BIOS or UEFI. We'll just call it BIOS, keep it simple. Again, this is our chipset we talked about before. So we first turn the computer on, the BIOS comes on first. Again, it does its checks. CPU, memory, and so on. Then it's going to say, all right, is there anything to boot? It might check USB. We got to be. That's a horrible looking question mark there. It might be, is it going to check USB? Is it going to check maybe DVD? If you still have one, DVD tray and so on. Even back in the old day, it would be floppy drive. And so, I'm not going to look at the hard drive. It's told to. It could be several hard drives. Hard drive, you have an OS. Hard drive says, yes, I have an OS. This is our boot. This is our sort of part one of our bootloader. Part two, the OS takes over. And the OS loads. And the OS is going to go and it's going to load what's called the kernel. The kernel is sort of the lowest level part. It is the core of our operating system. And it depends on the operating system. So Windows is what's called monolithic, very large kernel, but it has a lot of stuff, a lot of drivers built in to handle any kind of hardware. Mac is more customized because Mac OS is customized for the hardware. Linux is a modular, very, very small kernel and only loads what it needs. So the kernel itself is very different, but again, the underlying functions, like we saw before, and then with that little brain cloud diagram are the same. Just when it loads, though, it's going to load separately. Either everything it needs all at once, like Windows monolithic, or might load just the kernel itself and then start loading only chunks what it needs, very modular. So our kernel takes over. It's going to have what's called services, GUI being one of them. It might start the GUI up, and then it might start networking, and it might go and turn on login, allow login in, and when we see our login screen, and this is all really, really fast. This could be going on in 1 second, under 1 second. So for us as carbon-based life forms, we're like, oh, that's quick. Before we know it, it's up and running. Even when we get our login screen, there could be still stuff firing up in the background. So again, that's how we look at booting. We talked about this already. And of course, after the boot's done, we could be starting processes. It could be looking for updates. It could be checking network for backups. So all these little things that run in our background, it could be doing. So we'll clear that off. So this is a little section about yesterday's operating systems. It's pretty cool to look at. I'm not going to cover this, so. But it's pretty cool to go back and see the different operating systems in time. I will pick up here, talk about multitasking and task switching. We know as alt-tabbing in Windows, running multiple things at once. In reality, with multiple cores, multi-core systems, we do actually have things running at the same time. Back with task management with one single core, you actually only do one thing at a time. Just it does it really quick. It can switch between those so fast that we think it's doing multiple things. All earlier operating systems, which you'll see in that chapter, we'll talk about like MS-DOS, single task. It's all it does. What you see running is all you get. So as we know nowadays, though, multiple task switching is definitely there. Our phones, multiple things can be sort of frozen and come back to an update later, or actually update in the background. So task switching, multitasking is a huge part of our operating system. I talked about this already. Folder and file directories. A folder, most people hopefully know this. When you get into Windows, let's look at Documents, right-click, a new folder, right? That's our file management system in place. And in there, let's do a new text document. And then when I double click on it, it knows based on the Microsoft OS, which we'll talk about later, in the Notepad. It gives me my GUI. I hit save. It's going to use the file management. It's going to actually create and write that file to space. So files, folders, partitions, HSD. We talked about that already, so we're good there. File management, look at that later. Device drivers, I talked about it already. Device management, again, we talked about that already. So memory management, I think that's pretty much straightforward. Security, what else we got? Security, password protections, authentication, big part of security. We'll come into the security chapter later, but there's, of course, authentication and authorization. Authentication, your name and password. Authorization, what are you allowed to do with that name and password? Are you allowed full admin access? And that's something we're going to look at in this course. Administrator or root. In Windows, you have administrator or root access in Linux. And they, of course, have administrators access to everything, change underlying OS functions. Normally, you wouldn't want to run as a regular user, which means you have to either give a password for root or authenticate to become root. So again, more on chapter 2. And the last thing, of course, here is our today desktop systems, Windows 7. So why is this still around? Well, it's still around in the workforce. 2009 it came out. It's still here, and it is used still immensely. So we'll look at Windows 7 in the course. Windows 8. Well, there's a slide deck thing on it to talk about it. We're not going to talk about Windows 8 in the course other than this. It came, it went. It was never really a success. So Windows 10 came out though, and this is what really is the main OS now. It is becoming the main operating system for, you'll see in most enterprises and workplaces. Mac, been around for a long time. 2001 though, we look at the OS 10, so the current Mac, based on Next Step or Unix or BSD Linux backend. We'll look at that in chapter 7. Linux actually is sort of an offshoot of Unix. Started in 1991, as it was actually, we'll talk about Unix more in detail on the Linux chapter, but it's become really huge, and we're going to go over links in the class, so you're going to learn some Linux stuff here, as well as different operating systems. Chrome OS. So this is a chapter on Chrome. We'll talk about Chrome. It really is just a browser-based OS. And it sounds funny, but the browser being really the heart of what most things you work with, right? eLearn, for example, watching this video, all done through a browser. So making an entire OS from the browser sounded crazy at first, but it has become a pretty mainstay, and it's used in a lot of schools. You may have already used it too. So we'll talk about Chrome OS and mobile. A couple sites on mobile, we'll wrap it up. We have Apple and Android. Even Windows, as I heard, is coming back. But it actually have an Android underneath the hood, I sort of heard, at least at this date when I recorded this. That's what I sort of read. But really, Android and iOS are the two main camps. And that's basically it. One last note here when it comes to different operating systems. So you might say, well, if we were in person, you might say, well, Professor Mike, Dr. Mike, what's the best OS? They're all good. I have Mac here running in front of you right now. I have Windows on a gaming system down here. I have Chromebook over here on another system. I have a laptop with Linux on it, System 76. When they work, they're great. When they don't work, it's frustrating. And as we go through this class, you say, well, I've never done Mac before. I hope that when we get to Mac, you'll learn something. It's not a class to sell you on an OS, and don't come in thinking, well, Mac sucks. I hate Mac. Well, you may never used Mac before. Even if you have used Mac, you don't like it. There's some stuff we want to take from the classes, but you can carry it to your first job or your next job interview. And then go, well, that's great. You don't like Mac. Well, you never learned it because you don't like it. Well, we have Macs here, so I guess you're not going to be a candidate. Well, you can come around and say, well, I understand how to use Mac. I know how to find the user profiles. I know how to set up security or firewall. I understand the basic settings or where files are held at. It's going to make you a more valuable job candidate. So again, we're here to look at all these OSs really from a corporate or industrial level, not from I'm trying to sell you a Mac or a Linux laptop or an Android phone or an iOS phone. So keep that in mind. Keep your mind open. As we come to each OS, you'll learn some new things, and including virtualization here, which we'll talk about probably in a couple weeks. In any case, that wraps up the chapter. and we'll see you again for Chapter 2, which is Computer Security. Thank you.